Good morning, everyone. Good morning. Welcome back. Thank you for joining me in this part four of this part of the episodes, Pythagorean triplets and higher orders. Over the previous few weeks, we've sort of combined two topics together, the Pythagorean triplets, higher orders, and also the Euler's sum of powers conjectures, which admittedly I didn't quite realize was a topic in and of itself up until maybe 2 years ago. I was experimenting with the Pythagorean triplets, etc., and then realized maybe we can raise the powers there. I thought it was simply a cognate of the Pythagorean triplets and higher orders, but turns out, yes, Euler did do his own work on it. I uncovered a bit on that in the previous episode, but here I find these things, let's say, more interesting, seeing as there are more avenues to go down, and those avenues are easy to explore when you have some of the most powerful computing programs in the world. So here on the screen, you'll see these are the solution for something around a while ago for the this Pythagorean quintuplets here. And this is the script that we wrote in C sharp last week. I think it was 2 weeks ago, maybe last week. So what I want to do now is I'm not exploring anything a bit new, but what I want to do is I want to take this script in C sharp and I want to translate it into Python. A few reasons why. You'll recall when I was in the first episode of this part of the Pythagorean triplets was I explained where I was trying to install Visual Studio on this new computer. I was having all sorts of difficulties. I think that was the point. I installed Visual Studio and it didn't quite work for what I wanted, and then I had to uninstall it. And what I really wanted was Visual Studio Basic, so I had to go through all of that again. I had to uninstall things. I had to reinstall some things on the PowerShell. To disable some things. It wasn't a great process. And in the meantime, while I was doing that process, simply to have C sharp up, they asked me, do I want access to, I think, Java or C, something like that? Rust? I can't remember. They asked me if I wanted something. I don't think it was C. But I thought, I'll get that, seeing as I don't want to have to do this again. And it was only after the fact, maybe a day later, where I thought, I think I might have wanted Python in here. Python's quite useful. I might want that in my life. Um, so then I had to do that whole thing again, where I had to go back through the installer and bring Python here. It was a whole faff. Um, Again, I said I could have produced a whole video on installing Visual Studio. I could have produced a whole video on reinstalling to allow for Python. Let's not get into that. Another reason why is I was speaking to a close personal friend of mine, work associate. She is quite keen on Python, and she talks about some of the work that she does on there. She finds it a much better tool, and from what I hear, there are positives and negatives, I suppose. But Python, I hear, is streamlined. The syntax is easier, so they say. It's cleaner syntax. It results in shorter scripts, more efficient scripts. Again, so they say. And another important point is that it has access to API mainframes, which I have a few ideas of what I want to work with later on, so I'll keep that in mind. So Python, I'd give this a go. So I'm going to continue on. I'm going to write, let's say, a cognate for this script for the Pythagorean quintuplets in Python. So let's do that now. If I go to another instance of Visual Studio where I've already opened up Python, let's get on with it. So first of all, I'm going to bring all of the packaging tools here. So I made the point before. I have no idea what any of these packages actually do. It's sort of only after the fact when I've written the script, or while I'm writing the script, that I have no idea why things don't work. You'll recall the big integer function in C sharp, which always caused me a problem. I realize it needs the collections. Similar here, I have no idea what any of these packages do. If anyone in the comments could help me out, then that would be really helpful. And I see I've already made one mistake so far. We don't use static mains in Python. I believe it's simply a definition or a def. So I'm gonna just simply omit that. So definition main, and it's got a red squiggly. I think that requires a semicolon. No, it's a colon. It's a colon in Python. I'm gonna have to get used to that. So print. So remember, the first thing we wanted to do was to pre-compute those fourth powers of A and B. So let's do that first. So introduce the fourth powers, which is simply for all instances of A and B, but we're going to use a dummy variable I. So remember, we're using this double asterisk notation instead of a hat to indicate powers of. So for I within the range of max E plus 1, okay, and then we need to create that definition. So we're creating the calculation for the fourth powers, but we actually need now to create that definition. So building some dictionary of a to the 4 plus b to the 4. Okay, so let's remind us actually what is the problem we're trying to solve here. So I want Pythagorean quintuplets, and I'm already getting an issue here because that's not how you omit lines here or cancel lines. It's the hashtag. Pythagorean quintuplets. And what is that? That is a to the 4 plus b to the 4 plus c to the 4 plus d to the 4 is equal to e to the 4, right? So now let's create that dictionary. So sum map equals the default dictionary list. Okay, so here we introduce A and B. So E in the range of 1 max, the maximum E value plus the 1, because remember it's indexing, so it starts really from 0. So 1 is a 0 index. The maximum E will be 999, but we want 1000, so we have to add the 1 to it. Introducing B now for B in range of A to the max E. Again, so we're not doubling our efforts by starting B all the way from 1. We don't need to. Otherwise, if we get a solution for A, I mean, it doesn't really matter. The solution will come out. So you can argue that the A, B, C, D could equal whatever they are. They could be any combinations, but the E has to be fixed. So now we introduce this parameter S, which is shorthand for A to the 4th power plus, was it B to the 4th power? Yeah, so that's that shorthand sum here. So we're going to conjoin, let's say, the sum map, the dictionary, with this function s. So whenever we find, no, this is the append here is adding those values a and b there. Okay, so let me say that again. The sum map is the dictionary. We're defining that as a dictionary, whereby we're running these a and b to the power of 4, and that sum here is what's going to be built into the dictionary. So the sum map is linked to that sum map together with the parameter definition of s. Okay, so then the append is what's actually adding it to the dictionary. Without it, nothing is being added to the dictionary. So another interesting point here is that I don't know why, but when I press the enter, it's automatically aligning with the last line here. But I know that's not often the case. You can see I pressed enter on this line here, and I automatically was sent down an indent. Story for another day. So now I need to go back. If anyone knows why that is, please let me know. Console write line. Wait, no, that's not how we do things. We don't console write line here. Print. So now while that's doing, we actually need to find a function for the quintuplets. So searching for quartic quintuplets. So I've made that point before. I have no idea why the indenting is aligned to the left, etc. Level. I have no idea. I also have no idea why I need to end things with a semicolon or a colon now in Python. I have no idea why we end things with a semicolon or not. I have no idea why we. So I have no idea why we need capital letters in certain cases. I also have no idea what any of these packages do. So if anyone knows, please help me out in the comments. So what we're doing now is I'm adding the definition for C and D, but for that I need to align C and D with the range of E, so the right-hand side parameter. So that's what I'm doing here. So now we're introducing C. So C is now going to be in the range of 1 and e to the power of 1. For D in the range of C e to the power e plus 1. Sorry. Oops. Okay. CD, some new C. So I'm going to do the same. I need a shorthand version for C and D, the 4th powers of C and D added together. What am I doing? Yep, T, D. Okay, and I'm going to create this target, which will be the difference. So E4, and I'll explain this in a minute. Okay, so think we're good so far. No issues found. That's great. So, what did I want? CD sum is equal to the fourth power of C and D. So that's this part of the left-hand side now. And the target is E4 minus the fourth powers. So this minus this is the target. And the aim is that if we can find this target, which is equal to an A to the 4 plus B to the 4, it'll basically fall under this dictionary that we've already computed. So the dictionary will stay in the background. We don't need to keep calculating it. That's purely for our reference. But if we find a target that also falls in that dictionary, then we know we have a solution. So we need to carry that out. We need to enact that. So how do we recognize that? So sum map. If the target is in the sum map, so for A and B in the sum map, you'll see as I'm typing, I'm getting all sorts of prompts or cues from. See, it was helpful when I was doing this, but now I'm not sure if it's simply annoying you. It was useful for me when I was doing this. Um, I realized when I don't have the semicolon, it aligns to the previous line, but it's telling me I need the colon, sorry, and it's gonna give me an indent. Sorry, okay, so that's great. That's good. That's interesting. I need that. Okay, so values come back here. What was I saying? I was making another point, and I've forgotten what that point is. To be continued. Comments, let me know what was the point. Sorted. So, okay. Oh yeah, these boxes. There we go. I was insulting the boxes, but now they've come to my rescue in helping me find my trail of thought. You can see they were annoying before, but when I was writing this, it gave me clues as to what I wanted the next part of my script to be. And there's another thing you'll notice. I'm hitting the control button. Well, I see it, and it's central. It's zeroing in on my cursor, indicating where it is. It wasn't doing that before. Maybe it's the screen recording tool I'm using. I don't know, but it's here, and there we go. There we go. Okay. Concentrate. A, B, C, D. So remember, if the difference here between E, C, D sum, the CD sum and the E4 is also in the dictionary, that means A, B, C, and D is a solution. All we need to do now is find E. So that is what the next part is. So the key tuple, this is where we actually solve for E. So the values plus E. So we're combining the values. It's not an actual arithmetic sum, but we're using those values here. We're raising them all to the power 4, and we're simply finding what that E value is. Okay, and we need a null statement. So if not seen in the dictionary, then otherwise what? I was a bit confused by that, but anyway, this is it. If it's in the dictionary, we're adding it. If not, then we don't need it. So this is what we're adding it. We're basically adding the key. Again, the append. We're adding this to our list of solutions together with that E. Otherwise, if it's not, we simply ignore it. That's a bit of an offhand way to write it. I prefer the way in C# how they do that. So I think that's it. All we need now is to actually 35 lines so far. That's good. So all we need to now is simply output this. Okay, so or at least find a way to communicate with the static or the PowerShell. Okay, so search complete. This is the last thing. Hence we can close that, and then we can print n solutions. Right. So I like that. Remember the backslash n was what we used in C# to indicate a line space. So I was way back in episode 1 for prime numbers. I was trying to figure out why we couldn't do this for a certain function, and we had to. It was console write line that we had to use, but console write line wasn't working. So that is another way to do it. So in results. Results. Concentrate. U. And the solutions are simply A, B, C, D, E equals sol. So now we can console write line. Print. So F. F is the. Why do we need F? F is to do with the decimals. I can't quite explain that. Someone in the comments help me out. Or I'll get back to you on that. B. So B. Let's write this on out. B. C equals C. Whatever those C's are. So remember, the curly brackets indicates that it's something we've calculated before, and the D these without the curly brackets is simply a parameter definition that I'm setting. Okay. So I think that's fine. And I don't know why, but in order to end things, you need this line here. I couldn't understand this. Maybe this was sort of my own wording, for example. I don't understand this, but for some reason I needed this main here. And if anyone knows why I need this, again, please let me know. So I think that's it. Here we got 44 lines compared to the 66 lines that we had earlier. But I think a lot of those lines were simply, when I was doing things like this before. Remember in C sharp, we simply add 4 lines, also 2 lines, simply by these bracket definitions. So I'm ready to run this, and it's not letting me run it so far. Hang on, let me see if I can run this. Okay, I've run this now. So let's see how long this takes. C sharp. Well, I'm not benchmarking. I think C sharp was slightly quicker when I did this. I've worked on this script, this Python script. I did this last week, so I'm sort of recalling it from memory. I think C sharp was slightly quicker. There we go. Okay, that's it. Yeah. Okay, there we go. So let's bring that up. I think we also had the solution from C sharp. So let's bring. Yeah, it's the same, isn't it? So there we go. I think we're done. Found the same solutions. And that's it, isn't it? So nothing more to this. That's it. I've simply converted the script from C sharp to Python. So if I go back here, there we go. That's it. Simple 40. Oh, again, simple. I had trouble. It took me a while when I was writing this. So I'm quite keen to see what the founding fathers of this thought. Leon Lander, Thomas R. Parkin, John Lewis Selfridge. I'm not sure. Well, they're not with us anymore, so there's not much literature left from them on this. Noam Elkies is still around. He's a professor of mathematics in the University of Harvard. Roger Fry, who came up with, let's say, the smaller solution to the Euler's sum of power conjecture, quadruplet. I'm not sure what he's up to. I couldn't find anything on him. Anyway, there it is. Guys, I'll end this here. So we've discovered, or we've explored Pythagorean triplets and higher orders, and it doesn't seem there are any limitations there. We looked at Euler's sum of powers conjecture, and that's been disproved first in the quintic case from Lander, Parker, Selfridge. There is a solution at k equals 3, k equals 4, and k equals 5. K equals 5 is the absolute best it seems we can do. It is theorized that there are, a conjecture, I suppose, but they use theorized. It theorized that there is a solution at k equals 6 and all others. In fact, there is a solution at all cases for Euler's sum of powers conjecture. However, we simply haven't discovered them yet, and in theory they are there. So k equals 6 is undiscovered, but k equals 5 is the best we can do. We have a solution. Again, it's computationally more expensive, and it's not going to be discovered by me on my Dell computer. So I'm curious if any current students or followers of Noam Elkies can put this video in front of him. Please do. I'd be grateful to see what he thinks. Um, so not remember 1966, August 25th, 1966 was when Noam Elkies was born. So as sort of a treat to him, that was when I released episode 1 of this Pythagorean triplets. So the original script, the looping script. And that was also the 1966 was the year when Lander Parker Selfridge discovered or disproved the Euler's sum of powers conjecture. Anyway, I'll end that there. So again, as always, if anyone has any comments, questions, criticisms, anything at all, happy to address them. Write them in the comments and let me know. As always, hope you find this useful and hope you find this entertaining and helps you see what you're currently learning or what you did learn and study in school in a broader light, let's say. So what day is it? September 15, 2025, Monday. I'll get this video out shortly. And we'll see you possibly next week. I might have something to do, maybe the week after. I don't know. I'll have another topic then. Thank you very much for joining. Thank you everyone so much for joining, and I will see you soon. Thank you so much.